All right, hello everyone. Today I'm going to be going over the test review for the upcoming test. The file for the test review should be attached to this announcement. So what I would definitely recommend is instead of just watching the video and writing down all the answers that I put, take it, like print it out for yourself or just like write down the answers in your own notebook, and then just compare them to mine. I should have in the video, in like the description, like little timestamps for each question. So if you're only looking for like the answer to number 8, you can just click to that spot in the video. And that could help you out. But definitely if you want to watch through all of them, you can as well. But I would definitely recommend instead of just watching the video and seeing them done, do them yourself first and then check with me to see if they're right. All right. And then I'm only going to have like a brief description of the questions. I will read them out in total, but you have access to it yourself. You can like split screen it when you're watching this video. So for number 1, it says use the given conditions to write an equation for the line in point slope form and in slope intercept form, passing through the point 8, -6, and perpendicular to the line whose equation is y equals 1 over 3x plus 5. Write an equation for the line in point slope form. All right, so we know that point slope form, that one's going to be our y minus y1 is equal to m parentheses x minus x1. And then when a line is perpendicular to another, what happens to the slope? So our slope for our original one, I'll say is m1 is 1 over 3. If it's perpendicular, then the slope of our new one will be flipped. So the fraction will flip, that'll make it a 3, but then it will also be negative. So our new slope is -3. And then now I'm going to start plugging into my point slope form. So we have y minus a -6 is equal to -3 x minus 8. And then if we just simplify this, the left side, so it's not a negative, we get y plus 6 is equal to -3 x minus 8. And that is your point slope form. So that is your answer to your first one. And then the second part just says, write an equation for the line in slope intercept form. Well, they're really just asking you to simplify this. So if I take my original, so y plus 6 is equal to -3 x minus 8. Distribute them. I get y plus 6 is equal to a -3x plus 24 minus 6 minus 6. Y is equal to -3x plus 18. And that is your answer for number 1. All right, number 2 is pretty similar to number 1. Kind of the same question. Use the given conditions to write an equation for the line in point slope form and general form, passing through the point 2, -9 and perpendicular to the line whose equation is x minus 5y minus 6 is equal to 0. And they're first asking for the equation of the line in point slope form. All right, so the first thing that I have to do is take my original that they gave me and get it equal to y. So I'll rewrite it down here. I'm going to minus the x and add the 6 over. So I get a -5x or 5y is equal to -x plus 6. And then I'll divide by -5. So I get a y is equal to 1 over 5x minus 6 over 5. But the only really thing we care about in this equation is its slope. So then the same thing happens here. Since it's perpendicular, my original slope is 1 over 5, and that will make my new slope, we'll flip the fraction and make it negative. So my new slope is -5. All right, so the first thing is point slope form. So I'll plug it into my y minus y1. So y minus -9 is equal to -5 parentheses x minus 2. And then just simplifying it just a bit, y plus 9 is equal to negative 5, x minus 2. And then for the second part, they're asking for it in general form. And they give you a little hint for it. They tell you it's equal to 0. That's what general form is. It's everything to the left and it equal to 0. So I'll start simplifying stuff out. So y plus 9 is equal to, if I distribute my negative 5 out, I get negative 5x plus 10. And then I'm just going to add 5x and minus 10 on both sides. So my answer is 5x plus y minus 1 is equal to 0. And that is number 2. All right, for number 3, it says find the average rate of change of the function f of x is equal to the square root of x from x1 is equal to 25 to x2 is equal to 49. So the first step is for this equation is finding your y1 and your y2. So plugging in f of 25, it'll be the square root of 25, which is equal to 5. And that is my y1. Then I'll plug in 49. The square root of 49 is equal to 7. And that is my y2. So now rate of change is kind of similar to slope. It's just going to be y2 minus y1 over x2 minus x1. That is equal to 7 minus 5 over 49 minus 25. That will equal 2 over 24. That's equal to 1 over 12. Ooh, there we go. So your average rate of change, which is what it was asking for, would be 1 over 12. For number 4, we get into some graphing. It says, begin by graphing the absolute value function f of x equals the absolute value of x. Then use transformations of this graph to graph the given function g of x is equal to negative 3, absolute value x plus 1 plus 5. And then she's asking for what transformations are needed in order to obtain the graph g of x from the original f of x. All right, so for f of x is equal to absolute value of x. I'm going to wait a little bit before I go through the struggle of drawing out my own graph. But just for you to know, the absolute value graph, it's not going to be a perfect V, but it looks like this. And then the starting point is at 0, 0. And then it goes up 1 over 1 as it increases. So that's our base of our function. And I guess I can draw a basic axis here. So for g of x, some of the transformations that are happening, the first one is asking if there's a reflection over the y-axis. There is no reflection, so no reflection. You'd get a reflection over the y-axis if there is a negative on the inside here, so like right there, but we don't have that, so sorry, jumped. So there's no reflection there. If there's a vertical shift, yes, there is a vertical shift. It's that ending point at the end. So there's a vertical shift up 5. Next one's asking for a reflection over the x-axis. Yes, there is, because the beginning of it is negative. So reflection over x. Next question is there a horizontal shift? Yep, on the inside, since there's an addition within the absolute value, or in other questions would be inside the parentheses, there is a horizontal shift. That's going to be a horizontal shift left 1. Then it's asking if there is a vertical stretch or shrink. There is a vertical stretch. That's going to be that factor on the outside. So it's going to be, since it's a factor larger than 1, or for simpler, you can just think it's not a fraction. Just be careful if it's like a fraction 3/2, then yes, it is still a stretch. But since it's greater than 1, it's going to be a stretch of a factor of 3. And then no horizontal stretch, that would be if it's multiplied on the inside of the absolute value. So no stretch or shrink. Alrighty, and let's get to graphing. Um, 1, 2, 3, 4, 5, 6, 7, 8, 9. I've learned with this, the more lines you draw, the easier it gets to get somewhat close to what the graph looks like. All right, so we're starting at the point, we're going to go left 1 and up 5. 1, 2, 3, 4, 5. So about right here. Then since we have to remember it's reflected over the x-axis, it's going to be pointing down now. And then I have to go, instead of up 1 over 1, or in this case, it would be down 1 over 1, I'm going to have to go down 3 over 1 because of my vertical stretch of 3. So one thing you could do if you're having trouble figuring that out is testing points. That's definitely going to be a lot more helpful on number 5 that we're about to do. So this one, like I'm about to graph at x equals 0. So if I plug in 0, I get 0 plus, I can actually do it down here. So f of 0 is equal to -3 absolute value of 0 plus 1 plus 5. That's equal to -3 absolute value of 1 plus 5. So then that's -3 plus 5. So that equals 2. So that tells me that it's going to be 0, 2. And then you can keep testing as many as you want. I'd recommend at least like 3 or 4. But that should give you enough to be able to graph some sort of line that represents your function. And that is number 4. All right, for number 5, it's another one of graphing. So it says use transformations of the graph f of x is equal to x cubed to determine the graph of the given function h of x is equal to -x plus 6 cubed. So this one is not asking for all the transformations, but I do think it's helpful to at least write them down. So I'll also draw our base one out. So f of x equals x cubed. That one's going to look like this. I usually refer to it as like a super stretched out S, but the more I look at it, the more I don't understand why I used to call it that. But it's going to be that one that kind of twists and turns as it approaches the, the x-axis. I'm going to draw it a little bit better. There we go. So same thing, most of these always start at 0, 0. So that's going to be like your inflection point, is where it kind of switches from decreasing. Well, it's not technically never decreasing in its increasing value to rapidly increasing. So some of the transformations that are going on is it is a horizontal shift to the left. So I'm just going to say left 6. And then reflection over x-axis. So if I get my graphing out, All right. So the first point I care about is my center point. So it's shifting from 0, 0, left 6, no vertical up or down. So all I have to do is go left 6 from 0, 0. So 1, 2, 3, 4, 5, 6. And this one, you might not know where to put your next 2 points. So this one, I definitely recommend going 2 to the left and 2 to the right. So we're going to do f of -9, f of -8, f of negative, oh, not -9, -8. -7 and -8, -5, and -4. So -7, that's going to be a -7 plus 6 cubed. So a -1 cubed, and that's going to be 1. Because -1 cubed is -1 times -1 is 1. -8 is the same thing, but with a -2 on the inside cube. 2 cubed is a 8, but -2 would be a -8, and then negative again would be 8. And then actually, if you go the other way, it would just be the opposite. So we'd get 1 for f of -5. And -8 for -4. All right, so my point -7, 1. And I'm not even going to count, but it's somewhere up here. And then same thing below, my -1 there. And then somewhere down here is that. And there you go. That is your h of x. Something like that. It'll be a lot easier on the test when you have some sort of graphing paper or something like that to do it on. All right, for number 6, it is saying find the domain of the function f of x is equal to the square root of 14 minus 2x. So what is the domain of f? So just some quick reviews. The domain is just all the x values. So really, they're just asking what x values can you plug into this? And that's going to be a lot of numbers. So we usually tend to think, what can we not plug into these functions? So with a square root function, we have to remember that it cannot be negative on the bottom or under the square root. So no negative under square root. So in this case, we don't want this, my 14 minus 2x, to be negative. So in other words, we want 14 minus 2x to be greater or equal to 0. It can be 0 because the square root of 0 is 0, but anything less than 0, it's going to be a negative, and we can't take the square root of that. So now I'm just going to solve for x. So minus 14, get -2x is greater than or equal to -14 divided by -2. I get x is less than or equal to 7. Because remember, when you divide by a -2 or you divide by any negative, you have to flip the sign. So I get x is less than or equal to 7. So this is my domain. If you want it in a different form, you could say the domain is from, if I think they were asking for interval notation. So that would be from -infinity to 7. And make sure you put a bracket on the 7, because since it's a less than or equal to sign, the 7 is included in your domain. So that's it in interval notation. I don't think there's any other questions for domain on the review. Just remember, if you ever have a domain question about a fraction, just equal the bottom of the fraction to 0. So like in this case, we would say our domain is x cannot equal 0, and that's our domain. If you have a 1 over the square root of x, that's where you have to do both. It would be x is less than, or actually, scratch that. We check for when x is greater than 0. So just take a second whenever you have these domain questions and think, what can x not be? Solve for when it's those bad values, and then make your domain off that. That is number 6. All right, for number 7, it says, given functions f and g, find f minus g. So our f of x is 8x minus 2. And our g of x is 6x minus 5. So I just have to do f of x minus g of x. As that's going to be 8x minus 2 minus parentheses 6x minus 5. You just have to remember to distribute the negative to your g of x when you're subtracting these. So it would end up being 8x minus 2x minus 6x plus 5. So combining like terms, I like to circle, underline, square all my like terms. So I get 2x plus 3. And that is f of x minus g of x. All right, number 8 has a few parts to it. It's saying for f of x is equal to x plus 5 and g of x is equal to 5x plus 2, find the following functions. I'm going to be honest, I don't know how to properly read them. But for A, it's f of g of x. Kind of looks like fog. But that's just basically saying I'm plugging in g of x into f of x. So you could also, another way that they might write this is f of g of x. So that one's just going to be plugging in 5x plus 2 for x in f of x, which doesn't end up being too complicated. You could put parentheses if you want to show that you are plugging in. And that just ends up being 5x plus 7. When you get to B, it's a little bit different. So this one is g of f of x, or you could say g of f of x. So now you have to multiply f of x by 5, because that's in g of x, it's 5x. And then don't forget the plus 2. So 5x plus 25 plus 2. Let me box this one so you can see it. So it's going to be 5x plus 27. And then for C and D, they're just kind of asking you to go back and plug in 1 for them. So for C, they're asking for f of g of 1. And that is equal to, well, if you plug it in through there, 5 parentheses 1 plus 7. So that'll be 5 plus 7. That's equal to 12. And D, f of, or no, not f. It's going to be g of f of x is equal to 5 parentheses. Actually, it shouldn't be x, it should be 1. F of 1. So it's going to be 5 parentheses 1 plus 27. So that equals 5 plus 27, which equals 32. One way that you could check to make sure that your f of g of x and your g of f of x are correct is doing this method, plugging into your original function. So like, take for example C, we had f of g of 1. So taking our function, we got it equal to 12. If you go back to your original, if you plug in 1 for g of x first, you get 5 plus 2 equals 7. And then plugging that 7 into f of x, we get 7 plus 5 is also equal to 12. So that shows that we did actually do it correctly for f of g of x. And then I'm assuming also as well for g of f of x. All right, for number 9, it says express the given function h as a composition of two functions f and g so that h of x is equal to f of g of x. And then h of x is equal to 1 over 6x minus 3. The wording for these are always complicated and it kind of gets tricky sometimes. But all you really have to do, whatever kind of looks like it could be on its own, make that your g of x. So I'm going to make the bottom of the function my g of x. And then my f of x, well, what do I plug in? If I make 6x minus 3, let's say equal to x, well, then if I go back to my original, that would make it look like 1 over x. Well, that ends up being my f of x. So my f of x will equal 1 over x. I wish there was a better way to explain it, but that is really the gist of it. Just make your g of x something that's containing more than just x. So it'll either be like what's inside the parentheses, what's under the fraction, what's in the square root. And then whatever your base is, just replace it with x, and then that'll get your f of x. Don't overthink it. And honestly, with whatever you make g of x, there is some way to make it f of x. But we're looking for the one that kind of covers the most ground with our g of x. So don't overthink it. Just kind of look at them. Look at your notes for some that were like the square root of x minus 2 or like parentheses x plus 4 squared. And those would be like g of x is equal to x minus 2, f of x is equal to the square root of x. This one would be g of x is equal to x plus 4, f of x is equal to x squared. So really, we're just taking the inside, making a g of x, taking the whole thing, making it f of x. All right, number 10 seems like a long one, but it looks like they're just breaking it up a lot. So it's saying the function f of x is equal to 3x, or not 3x. The function f of x equals x cubed minus 3 is 1 to 1. Find an equation for f inverse, the inverse function. So I'll do that first. So I'm just going to, how you find the inverse is you equal it to x, or switch your x's and y's, and then you solve for y. Add 3 over, x plus 3 is equal to y cubed. Taking the cube root, we get y is equal to the cube root of x plus 3. So that's your inverse function. Then part B says verify that the equation is correct by showing that f of inverse equals x and f inverse of f of x equals x. All right. So I'm going to do f of f inverse first. So that's going to equal, so the cube root of x plus 3 cubed minus 3. So that will be, these will cancel. So I just get x plus 3 minus 3. And would you look at that, that equals x. For the other way, f inverse of f of x, it'll be the cube root of x cubed minus 3 plus 3. So my 3's cancel on the inside. I get the cube root of x to the third, which same thing happens. My cubes cancel, so I just get x. So part A, it's giving you like this multiple choice. So the first part, they're just asking for what your f of x or f of inverse x is. That's going to be this right here. I shouldn't really put y. Should be f inverse of x is equal to the cube root of x plus 3. And then they're asking for the domain. Well, since the function originally says that it's 1 to 1, that means it passes the horizontal line test. So therefore, its inverse is continuous or is correct for all of x. There's no x value that I can't plug in for my f inverse that wouldn't work. So this is for all of x. Maybe the question doesn't tell you that your original f of x is 1 to 1. Then you could do what we did on number 6 and kind of find the domain of your f inverse and just make sure that there's no x values that you can't plug into your inverse. And then since we verified that for part B that we verified that they both equals x, the equation is verified. All right, number 11, it goes through the same thing. It's asking for the inverse of x plus 7 cubed. It also tells us once again that it's 1 to 1. So I'm just going to go through this one a little bit quicker. It is basically the same thing, except instead of we have a cube root, it is now cubed. So my x equals y plus 7 cubed. Take the cube root. We get x cubed equals y plus 7. Minusing the 7 over is that. So my f inverse of x is equal to the cube root of x minus 7. And we could really check this. Plugging in f of x here, it cancels the cubes. We get 7 minus 7. Doing this also, if we plug f of -1 into here, my 7's would cancel. I just get x cubed, or the cube root of x cubed, which ends up being x. So I'm going to go through the whole process of checking that. And it actually ends up being the same thing again for, so like for A, with your multiple choice, you'll write down your f of x is equal to this. And then since it's 1-to-1, once again, it is for all of x. You can go through the process of verifying it. It should work. You'll get both of them equal to x. And then once again, once you get it's equal to x for both of them, your equation is once again verified. So that's really the gist of 11. If you do get stuck, just kind of try to follow the process for number 10. All right, for number 12, it says find the distance between the pair of points -5 square root of 5, comma 2 and -4 square root of 5, comma 4. All right, so if we remember our distance formula, it's going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. So I'm just going to list my x1s and x1, x2, y1, y2. So x1, y1, x2, y2. So now I just plug in. So it's going to be -4 square root of 5 plus 5 square root of 5. That's going to be squared plus 4 minus 2 squared. So I know a lot of people were having difficulty adding together these like -5 square root of 5 and -4 square root of 5. What I would say is in your brain, think of the square root of 5 as x. Square root of 5 equals x. Well, if you replace this, like what's in here, it would be -4 of x plus 5 of x. And we can all do that. We've done it before. That's equal to x. Well, the same thing happens here. The -4 square root of 5 plus 5 square root of 5, well, them added together would end up just being the square root of 5. And that's going to be squared plus 4 minus 2 is 2 squared. So then we get 5 plus 4, because remember, the square root of something squared ends up just being whatever's on the inside. So the square root of 5 squared is equal to 5. 2 squared is equal to 4. So we get 5 plus 4 under the square root. So that's equal to the square root of 9, which is equal to 3. And that is our distance between the points, 3. All right, number 13 is same concept, different question. Find the midpoint of the line segment whose endpoints are given. So the 2 points are -3, comma -1, and -8/3, comma -3/5. So the midpoint, how you find those, you're basically taking the average between them. So it's going to be x2 plus x1 over 2, comma y2 plus y1 over 2. Once again, just make sure to label them correctly. And then plug in. So we get -8/3 minus 3/2, comma -3/5 plus, or minus 1, sorry, over 2. So I would recommend a few people in class when they had the fractions in this midpoint where they were dividing both first. I would simplify your fraction on the top. So the two things that we have to change is this -3 and this -1 so that they can be combined with -8/3 and -3/5. So I'm going to rewrite them as -9/3 because that still equals -3. And then this one would be -5/5 over 2. So those equal, that's going to be -17/3 over 2. And then -8/5 over 2. When you're dividing a fraction, so like when it's a fraction over another kind of fraction, just multiply the bottoms together. So this will give me -17/4. Or not over 4, apologize, over 6. And then for the other one, it'll give you -8/10. But then that could be simplified to -4/5. And that is your midpoint, -17/6, comma -4/5. All right, number 14, it says, write the standard form of the equation of the circle with the given center and radius, our center being 5, comma -2, and our radius equal to 6. So it's really just asking for the standard form. So remember your equation for that is, oop, already started off bad. That is your equation. X minus x1 squared plus y minus y1 squared is equal to r squared. So then obviously your center point, that is your x1 and your x2, or x1 and y1, sorry. And then r is equal to 6, that's your r. And then just plug in. So x minus 5 squared plus y plus 2 squared is equal to 36. And that is your equation for the circle. Number 15 is a fun one. I would definitely make sure you know how to do this. It kind of combines a lot of concepts that we've learned both in this unit and then also before our last test. So the question is: complete the square and write the given equation in standard form. Then give the center and radius of the circle and graph the equation. So our equation is x squared plus y squared minus 2x minus 8y minus 19 is equal to 0. So the first thing is they want the equation in standard form. So the first thing I'm going to do is rewrite this a little bit. So I'm going to get my x's closer together. X squared minus 2x. And I'm going to leave a blank spot. Plus y squared minus 8y. Another blank spot. And then I'm going to add over the 19. All right. And if you don't remember what we're doing here, we are going to complete the square not only once, but twice. You must love the complete the square method so much that we get to do it twice here. So remember, you take your b, so that's going to be your coefficient of both x and y, divided by 2 and square it. So this ends up being equal to 1. My other one, negative 8 divided by 2 squared, that ends up being 16. So that's what I'm going to put here, a plus 1 and a plus 16. But then also remember, you have to add it here. So plus 1 plus 16. So my new equation is x squared minus 2x plus 1 plus y squared minus 8y plus 16 is equal to, that ends up being 36. Now we factor these. If you forget, because it should be in the form, what we're looking for is for it to look like the circle. So it should end up looking something like this. If you forget what number goes here, take the answer to this. So negative 2 divided by 2, that's negative 1. So that's what goes on the, so these are actually end up both being negative. It ends up being a minus 1. And this one, negative 8 minus 2, ends up being a minus 4. So that's what our two factors will end up being. So x minus 1 squared plus y minus 4 squared is equal to 36. And that's our standard form of the circle. If you're looking for the center, you just take your values here and here. Make sure you flip them. So your center is 1, 4. And your radius, it's going to be the square root of whatever's there, because that equals r squared, so it'll be 6. And then now you can graph your circle. I'm not going to take too much time on this one because there's only a few things that you have to remember with graphing a circle. So graph your center. So 1, 4. Center is going to be right here. And then you just go 6 in each direction. So something like that. So 6 up, 6 down, 6 left, 6 right. And then do your best to draw a circle. Oh, I was doing so well until the end. And that is really it. So really make sure you know this one. This is completing the square to get the circle equation. I'd be surprised if this wasn't on the test. So definitely make sure you got this one. Review your completing the square because you have to do it twice. And please remember to add them to both sides. Add them to the ones to make it so that you can factor, but also add it to that right side, or else your answer is going to be a little bit incorrect. Well, that is the entire review. Good luck on your test.